The growing marshmallow. Okay. Now it's full size and it's starting to lose all the little bubbles inside, so it's going to start shrinking back down until it gets back down to normal size. But all the little gas bubbles have gone out of the marshmallow. Now we start letting the air in. Watch it. Now the air is pushing down on it, pushing, pushing, pushing.
Oh, look at that.
That is one sick marshmallow. So we're talking about atmospheric pressure, and I know that everybody is feeling a lot of pressure. So can we continue a bit?
Yes.
But what did you think about the little frog in the marshmallow?
That was a very
That
good
was pretty neat,
demonstration.
wasn't it?
Yeah.
Some of you didn't think it would get big when we made a vacuum.
It didn't make, yeah.
But when they make marshmallow, it's got all those little bubbles in there. Some of you like bread, and when we make bread, we mix up the dough, and then we put yeast in it. And the yeast makes little CO, carbon dioxide bubbles, which makes it light and fluffy. And marshmallows kind of do the same thing, only not with CO2. And so when we make a vacuum, all that gas comes out. And so it gets bigger, and then as the gas escapes, then it starts going back to its natural size. But now all those bubbles are gone. So when we put the air pressure back on, it gets crushed into that little thing. That was pretty neat, wasn't it?
That was really neat, yeah.
Yeah, I thought
like
that was pretty cool. But there are things you can do with atmospheric pressure that are even more astounding. In fact, something that I think would surprise a lot of people. Did you know that you can boil water?
Me personally? Yeah.
You can, okay. Yeah, if you heat water up to 212 degrees, it boils. It's called the boiling point, right? But it's a little more complicated than that. It's 212 degrees at sea level. But if you take your water and hike up to the top of a tall mountain, you're so high up that there's less air pushing down on you, so there's less barometric atmospheric pressure, and so the water boils at a lower temperature. How come? Remember, water are molecules floating around in liquid form, and when they get hot enough, some of those molecules escape out of the liquid into water vapor or gaseous form. And how hard the air pushes down on the water determines what temperature it takes to make it boil. Does that make sense? So on a high pressure day, water is going to boil at a different temperature than on a low pressure day. And if you take it way up a mountain where the air pressure is lower, it will boil at a lower temperature because there's less pressure pushing down. Now, here's the question. So you can boil water below 212. Has anybody ever seen a pressure cooker?
Yes.
A pressure cooker is a big pot you put on the stove, and sometimes people put bottles in that they want to can with, and they want to kill all the bacteria. But 212 degrees isn't always quite hot enough to kill the bacteria. And so that's why we have a pressure cooker. And the pressure cooker has a little place where steam comes out. You put water in the bottom, heat it up, steam starts coming out, and then you put that weight over the opening, and it blocks off the steam. And since the steam can't get out, the pressure gets higher and higher until finally there's enough pressure to lift the weight. And the weight is a very precise weight for that particular pan. And so that raises the temperature above 212 and gets it hot enough to sterilize the food. So that's called pressure cooking. And it just takes a little pressure to get it to boil at a higher temperature. If you go into a hospital and they're going to prepare instruments for surgery, they put them in an autoclave. That's a steam sterilizer, but the steam has to be hotter than 212, so it's a container that closes, and you can then pressurize it so the steam will get hotter. What I'm wondering about, what if you put it in R51's container and you pull out some of the air and make it a vacuum? How low of a temperature can you get the water to boil? Do you think you could do it at 210 or maybe 205? Maybe we could set a world record and get water to boil at 200 degrees Fahrenheit. How many of you think we could do that? Okay.
A world record.
What about 199? That'd be a world record, wouldn't it? To think that you could get water that's only 199 degrees to boil, that would be amazing just by putting it in a vacuum. Is anyone noticing that she's not very impressed?
Yeah,
We should have rehearsed this.
we should have.
Can you-
Tell me what I
Can
should
you give
be.
us just a quick timeout? Now, when I say this, oh, wow, that'd be great. Okay. So how many think we could do that?
I do. Oh, wow, that'd be great. Wait, how did it go? Tell me again. I think you can do that.
I am definitely operating under pressure today. Okay. Well, I wasn't sure how low of a temperature we could get water to boil. So I did a science fair project to find out.
Yeah.
I asked R51 if he could put some warm water inside that vacuum chamber and then put a thermometer probe in so we could see how hot it was. So we could watch the temperature and then pull a vacuum, and as the vacuum develops, I wanted to see if it would still boil. Now I know you can make water boil a lot cooler than 199 degrees. But what if it was only 190 degrees or 175?
That'd be amazing.
That gets iffy. What would really impress me would be if we could get the water to boil at just 150 degrees. Most people have their water heaters in their home, you know, you fill your bathtub with or something. We have those set right around 130, 135 degrees. What if you get water to boil just coming out of the tap like that?
Well, that would be impressive.
That'd be really amazing.
That would.
And what if you could make it boil at 120?
That would be, yeah.
Yeah, now we're into the realm of impossibility.
Okay.
And I guess the real crazy thing would be, what if you could get it to boil at 100 degrees? Do you know what 100 degrees is? That's the temperature of the human body.
Yeah.
The human body, unless you have a fever, is 98.7 degrees. 100 degrees. What if you get water to boil at body temperature? Plain old water. That would be shocking, wouldn't it?
That would be shocking.
I think we should call up R51 and ask him to put some 100-degree water in his thing, see if we can make it boil. So there it is. Can you see the beaker? I can see the temperature is 100 degrees. You can see the gauge going down as the vacuum's getting stronger, but it's not boiling, is it?
Nope.
Okay, well, we tried. Now almost all of the air is gone. Just a teeny bit
Oh,
left.
what is it doing? It's boiling. You did it.
We did it.
You and R51.
Look, it's boiling.
Oh, it is.
It
Look
is
at that.
boiling at 100 degrees Fahrenheit.
That's impressive. Okay, I'm impressed now.